So for this first example, it asks you, it says add the first 8 numbers in the following series. You can do this without formulas. I know you could. You could just find the next couple of numbers and then, until you have 8 and then add them together. So let's do it. How do we know if this is an arithmetic series?
Each of them are adding by 5.
It's adding by 5, so there's a common difference. How would we do that? I mean, do we want to use the formula? Let's use the formula.
Yeah.
Okay, so it's S sub n, right? But we're not going to say n right now because we know how many numbers are in the sequence or the series. How many numbers are in this series? 8. So we're going to have S of 8 equals, and then we have the number of terms divided by 2. Okay, right? N divided by 2, and then we have the first term plus the last term. Because I think doing this would be easier than adding them all together, right? So the first term is 7, and then the last term, what's my last term? Well, this is where we have to step back for a second and figure that this is an arithmetic sequence. The difference between each of these is 5, so it's going plus 5 each time, right? So I can find the next 2 terms. So that would be 37, right? And then 42, and that's the 8th term. So we have 42 right here. So we have 4 times, and then 42 plus 7, it will be 49. 4 times 49 is, let's see, I can't do this stuff in my head. Oh, so that's 6 and 3. So 4 and 4 is 16. We add the 3 to it, that's going to be 19, so we have 196. Right? Is that right? Yeah, I think so. Yeah, that's right. Okay, so our sum of the 8 terms is 196. Now there's other problems like we could have done that a different way. What if there's a problem like this? Like this one, for example, 2, it says add the first 81 numbers in the following series. I mean, before you were like, I don't need no formula. I'm just going to add up those numbers together in my calculator and I'll be done. But what if I said 81 terms? Oh,
then you would replace.
That's going to be a lot more work, isn't it?
You have to use that one formula.
I'd use that one formula?
Yeah.
Here. I know what you're talking about. Let me write stuff down so we can see what you're talking about. Okay, so we know that we're going to be using this, the sum of the first 81 terms. Okay, we're going to have an n dividing it by 2. We're going to have that term, and then we're going to have a sub what? A sub 81. Okay, so that's the last term that we're adding together, right? Okay, so do we know what that n is going to be right here?
81.
Yeah, that one's going to be 81. Do we know what the a sub 1 is? Yeah, we know that. That is 7. So how are we going to find the 81st term?
You have to use the rule of the...
Yeah, let's use the rule. What's the rule for this sequence? Now, it's a series because they're added together, but within the series we have a sequence. What's the rule? The a sub 1 is 7. A sub 2 is... No, you guys already told me the rule. Don't you guys remember?
Just
It's
it's add 5.
It's adding 5 each time?
Yeah.
So, do you guys remember the arithmetic sequence rule? A sub 1 plus, can you guys finish it?
A sub 1 plus A.
So
No, not plus, minus 1, yeah. So that's the rule, like the template we can use for an arithmetic sequence. Now we know the first term is 7. We're going to keep the n right there. Do we know what the d is? The common difference?
5.
Yeah, it's 5. And how do we know it's 5? It's because it keeps increasing by 5. Alright, so when I simplify this, I'm going to get a sub n equals 7 plus 5n minus 5, which would equal 2 plus 5n. Okay, so there's a sub n. Can we find a sub 81 now?
Yeah.
Yeah, we just have to plug it in, right? So we plug in the 81. Whoops, a sub 81. And that equals 2 plus 5 times 81. Oh. Ooh, what's 5 times 81? That's gnarly. Well, 5 times 8 is... That's 400. And then you have 5 times 1, which would be 5. So 400 plus 5. So or 405. And when I add those together, I get 407. So that's my last term that goes right here. So I'll put 407 right there. And now I can find my business right here. All right, so ooh, we're gonna get a decimal right here. That's kind of weird. We're gonna add all these numbers up, and we're gonna get a decimal. That's kind of different. 40.5. And what do we get when I add those together? 414. Okay, what is 414 times 40.5? Let's see. Oh, that's when I love calculators. You have to do all this other stuff right here with them. Okay, see, 5 times 4 is 2. No, is 0. And you put the 2 right there. 5 times 1 is 5 plus 2 is 7. And then we have 20. Placeholder. I'm not going to do the 0, so I'm going to do 2 placeholders so I can get over to the 4 right here. 4 times 4 is 16. Put the 6 right there. Carry the 1. 4 times 1. 5. Oh, you're just going to tell me the answer after I finish it. Okay, so we get that, and is that a 2?
Yeah.
Yeah, I can't even read my own writing.
That's one.
Okay, so I moved the decimal over once, boom. So I have my answer right there. It says 16,767. Wow, that increased rather dramatically there. That's the sum of the 81 terms. It's nice though that we had that trick because adding all those numbers would kind of stink in some context, like if we had to add them all together.
Wait, what was it?